Hello students, your professor Dr. Mink, and welcome to our next lecture on the topic of inheritance. We'll be covering the content from chapter 8 in your textbook. Inheritance is one of the key components of OOP, object-oriented programming. Let's get started. Here's a list of the key topics we're going to be covering in this lecture. Deriving classes, that deals with child classes being derived from parent classes. Method overriding, which we've already discussed in some significant detail already. The concept of class hierarchies, abstract classes, and obviously visibility and inheritance. Inheritance allows a programmer to create a new class that is derived from an existing class. The original or existing class is referred to as the parent class. Also can be referred to as the superclass or base class. Those three terms are interchangeable. They mean the same thing. So the new class or derived class is the child or subclass of the parent class. And as the name implies, the child class inherits the characteristics of the parent class. So what does that mean? That means the child class, the new class, derived from the parent class, inherits the methods and data that are defined in the parent class. Here we have a UML diagram that shows inheritance using a solid arrow with an unfilled triangle arrowhead pointing from the derived class or child class to the parent class. And inheritance creates and is a relationship. In other words, the child class is a more specific version of the parent. And in the examples on this slide, you can see a horse is a more specific version of a mammal. Mammal in this case would be the parent class, and the horse would be the subclass or child class. When planning a derived class, a programmer can tailor it by adding new variables and methods, or by modifying the inherited ones. Software reuse is a fundamental component of OOP, and it is a benefit of inheritance. By using existing software components to create new ones, we capitalize on all the effort that went into the design, implementation, and testing of the parent class. When establishing a derived class in Java, we use the reserved keyword extends, which establishes a child/inheritance relationship. So in the example here, vehicle is the parent class, and we're declaring a new class named car, which inherits all the methods and data of the vehicle class. And car then becomes a child to the vehicle class, or of the vehicle class, I should say. Next, we're going to take a look at a fully coded example of a project that uses a parent class and a child class. So in this example, the parent class is a class called book. Yes, it is a Java class called book. Okay, and book has a protected int pages 1500. It's a variable. Protected means only classes within the same package, or obviously this class or children of this class, can access that variable. It also has the following methods: a void set pages method, which sets the number of pages to whatever variable, sets pages to whatever variable is passed as a parameter. And also in get pages, which simply returns the value in pages. So there's the parent class. Now if you think about this, a dictionary is a type of book. So here we have a class, dictionary, which extends book, which means dictionary is a subclass or a child class of the book class. It also has a private int definitions. Definitions is set to 52,500, and it has a couple methods of its own. But remember, it inherits all of the data variables of the book class, and all of those methods can be used just as though they were declared right in this class. So we have compute ratio, definitions divided by number of pages. Definitions is a variable in this child class. Pages is a definition, is a variable declared in the book class. So we have a void method called setDefinitions, allows us to change the number of definitions in the particular dictionary. We also have a getDefinitions variable, which returns an int, allows us to access the number of definitions. So now let's take a look at the fully coded Java application, which utilizes all of these. So we have the class words that has a main method in it. We declare a new dictionary object using the constructor. Its name is Webster. And then we're simply system.out.println number of pages, Webster.getPages. Pages is not a variable in the dictionary class. It is a variable, well, getPages is a method, not in the dictionary class, but in the book class. But it's inherited by the dictionary, any objects in the dictionary class. GetDefinitions gets the variable, the value in the variable definitions from the child class. So here we have parent class, child class, child class. Now that's all you're going to get in the file that I'm going to put in Canvas. But I've added a couple other lines of code here, because all of these are just going to output and generate calculations based upon the output. I believe it was 1,500 pages and 52,500 definitions were the default initialized values of those two variables. So then I just put a print line with 3 new lines and a header, and I call Webster.setPages 455. So I redefine I assign 455 to the variable pages, which is in the book class, but inherited by any dictionary object. And I call setDefinitions, and I change that to 7,890. And then I have the same 3 lines of output. So let me run this for you. And here you'll see number of pages 1,500, number of definitions 52,500, and the definitions per pages, which is 52,500 divided by 1,500, comes out to 35. And then here's the new run, and remember I set the the variable values to pages 455 and definitions 7,890. So the definitions per page will come out as a different ratio. I hope this is helpful. As always, I strongly urge you to download the 3 files, put them into a package, build the appropriate associations, run this, and see what's actually going on. In this diagram, we see the relationship between the child class dictionary and the parent class book, and both of them are being accessed by the words application. Here we have some more information on the protected modifier. Visibility modifiers affect the way that class members can be used in a child class, and variables and methods declared with private visibility cannot be referenced by name in a child. They can be referenced in the child class if they were declared with public visibility, but public variables violate the principle of encapsulation. So there's a third visibility modifier that helps in inheritance situations, which is protected. And as I mentioned, protected variables, the protected modifier allows variables to be accessed by name in children classes and also in classes that are in the same package. So the protected modifier allows a child class to reference a variable or method directly in the child class. Otherwise, it would only be accessible by the object created. It provides more encapsulation than public visibility, but it's not as tightly encapsulated as private visibility. A protected variable is visible to any class in the same package as the parent class. So you want to keep that in mind, even though you may not be importing that class or utilizing that class. If it's in the same package and it's a protected variable, it's accessible. And in Appendix E of your textbook, there's a detailed description of all Java modifiers and the details on those modifiers. Protected variables and methods are shown in UML diagrams with a pound sign or pound symbol preceding them. So you should know that the parent's constructor is not inherited, even though they have public visibility. However, we sometimes want to use the parent's constructor to set up the parent's part of the object. So for example, when creating a new dictionary object, we might have wanted to set the number of pages when we create the object. So we can use what's called the super reference to refer to the parent's class, and it's often used to invoke the parent's constructor or part of the constructor. And you're going to see a fully coded example of the book dictionary class, subclass, parent, child class next in this lecture. So just hang on for a second. So now let's look at a variation, slight variation of the book class and the dictionary class. And in this case, we're going to build a class called Book 2. That's slightly different than the book class we just looked at. And we're going to have Dictionary 2. In Book 2, in the Book 2 class, which I have in front of me, the constructor has a parameter for the number of pages. So you could set the number of pages when you instantiate the book class. And it has set pages, get pages, etc. So now let's look at how the dictionary class uses the super reference. So this class is called Dictionary 2 and extends Book 2. It has definitions. Oh, but I point out that pages is the only variable in Book 2, similar to book. I just want to make sure that you saw that. So in this case, the constructor for Dictionary 2 has two parameters: number of pages, num pages, and num definitions. Now, in order to set the number of pages from the child class, we need to use the super reference for num pages. And that will allow us to access num pages right here in the constructor for book 2. So we're going to be able to declare a new dictionary 2 object and set number of pages and number of definitions with the constructor from the dictionary 2 class. If you recall, we had to do that with, I believe it was called the set pages method, which we had access to through the child class. We still have compute ratio, set definitions, get definitions, etc. So here we have a Java application that creates a dictionary 2 object called Webster. And when it calls the constructor for dictionary 2, we can now set number of pages, which is a variable in the book 2 class, and number of definitions. So I'll run this. There you go, number of pages 1500, number of definitions 52,500. If you want to see, because those are the same values, I'll just change it to 1588 and run this again, and there you go. It pulls right through. Hope this was useful. Thanks for watching. As always, you want to download these files. I put them in the timeline for Canvas, but you really want to feel comfortable using these, making sure you know what's going on behind the scenes, not just watching these videos. There are 2 types of inheritance, single inheritance and multiple inheritance. Java supports single inheritance, meaning that a derived class can only have one parent class. Multiple inheritance allows a class to be derived from 2 or more classes, inheriting the members of all parents. Collisions, a term which means the same variable name in 2 parents, has to be resolved in programming languages that support multiple inheritance. As mentioned, Java does not support multiple inheritance. Here is a graphic depiction of multiple inheritance where a pickup truck can inherit from the parent class car and the parent class truck. However, the use of interfaces gives us aspects of multiple inheritance without the overhead problems. A child class can override the definition of an inherited method in favor of its own. The new method, as declared in the child class, must have the same same signature as the parent's method, but it will have, or most likely will have, a different body. The type of object executing the method determines which version of the method is invoked.
Next, we're going to take a look at a coded example that demonstrates overriding methods between a parent and a class. Between a parent class and a child class. So here we have a new class named Thought. Doesn't have any variables, but it does have one public void method named Message. And simply, this is just academic in nature. It's just a demonstration to show what happens with overriding method names. So this method, all it does is print, I feel like I'm diagonally parked in a parallel universe, and then it prints a blank line after that. Okay, so we also have so that's the Thought class. We also have a public class named advice that is a child of thought. It extends thought. And it has no data. It has one public method, void method, named message, the same name as the method in the parent class. And like the method in the parent class, all this does is print out a string and a blank line. But then it prints out warning dates and calendars are closer than they appear, blank line, and then it uses the super reference, which allows us to call the method in the parent class. So pulling this all together, we have this Java application that declares, using the constructor, a new thought object named park and a new advice object named dates. So when parked calls or invokes the message method, it's going to go to thought, the parent class. When dates invokes message, it's going to go to the message in the advice class, which is the child class. And if you recall, the message method in the child class that prints that warning dates in a calendar. I still have my run from the last time. And it also invokes the method message in the parent class with the super reference. You want to see me run this? I will. But simply, I feel like I'm diagonally parked in a parallel universe. That's from the parent class method along with the space. And then warning dates in calendar are closer than they appear is from the overridden method in the child class. And then if you recall, it uses the super reference to call the method in the parent class again. So as always, I strongly urge you to run these files on your own. I'll put them in the timeline in Canvas. Thanks. So overloading versus overriding. Simple. Overloaded methods exist, multiple overloaded methods exist within the same class, but they have different signatures. Overriding deals with two methods, one in a parent class and one in a child class that have the same signature. Overloading lets you define a similar operation in different ways for different parameters. Overriding lets you define a similar operation in different ways for different object types. That's really the difference. Of course it is. And a class that is a child of one parent can also be the parent of another child, which forms a class hierarchy. And excuse me, here is a great example. So you have the parent class animal. It has three subclasses or child classes, reptile, bird, and mammal. But then within reptile, we have two. Reptile is then the parent to the snake and lizard class, child classes. Bird, parrot, horse, bat, mammal, etc. The features that are common to all child classes should be put as high in the hierarchy as possible, because a child class inherits from all its ancestor classes. And keep in mind, there is no single class hierarchy that is appropriate for all situations. One size does not fit all. There's a class called object, and it is defined in the java.lang package of the Java standard class library. And all classes are derived from the object class. It's the ultimate root of all class hierarchies. If a class is not explicitly defined to be the child of an existing class, it is assumed to be the child of the object class. So as I mentioned before, it's the root of all class hierarchies. The object class, excuse me, contains a few methods that are very useful, and they're inherited by all classes. So, for example, the toString method is defined in the object class. So every time we define a toString method in a class, we're actually overriding an inherited definition from the object class. So the toString method in the object class in the java.lang package is defined to return a string that contains the same name of the object's class along with some other information. The object class has a method named equals, and it returns true if two references are aliases. We can override equals in any class definition so as to define equality in some more appropriate way for the context of that class. We've also seen the string class defines the equals method to return true if two string objects contain the same characters. When the designers of the string class wrote that class, they overrode the equals method, which is inherited from object, in favor of an equals method that was more useful in dealing with strings. Here we see some methods included in the object class. You've got equals, you've got toString, and clone. Clone returns a copy of this object. Next, we move on to the concept of an abstract class. An abstract class is a placeholder in a class hierarchy that represents a generic concept. When a class is abstract, it cannot be instantiated. And we use the modifier abstract on the class header to declare a class as abstract. An abstract class can contain abstract methods that have no definitions, just like an interface. But unlike an interface, the abstract modifier must be applied to each abstract method. So, an abstract class typically contains non-abstract methods with full definitions, in addition to abstract methods. A class declared as abstract, it doesn't have to contain abstract methods. Simply declaring it as abstract makes it an abstract class, but it does not have to have abstract methods within the class definition. Any child of an abstract class must override the abstract methods of the parent, or it too will be considered abstract. So you can have a child of an abstract class that is not an abstract class. The abstract method cannot be defined as final or as static. And the use of abstract classes is pretty important in regards to software design. It allows us to establish common elements in a hierarchy that are too generic to instantiate. And we're going to take a look at this further. In this example, the vehicle class is abstract, and the common features are defined as appropriate in each child class. So they're abstract in the vehicle class, but defined as appropriate as needed in each child class. Here so the parent can refer to the private member. The child class must reference it indirectly using the methods inherited from the parent. The super reference can also be used to refer to the parent class, even if no object of the parent class exists. Now we're going to take a look at a coded solution that demonstrates indirect referencing. Indirect referencing of a private member of a parent class. So there's a lot of moving parts on this one, so pay attention, please. So here we have the parent class. It's called food item. And we've got a constant, final private int, calories per gram is 9. And then we've got a private integer, fat grams, okay, which is not accessible by an inherited class, or a class that inherits this. So a child class. So, and what we have here is the constructor, a food item, and the two parameters we pass are an integer, which is used to initialize fat grams, the private integer, and num servings, which is used to initialize the protected int servings. So, and we have a method called calories, which returns an integer, and another and that's public, and another method called calories per serving, which returns the calories per serving. So then we have pizza, which is a child of food item. But remember, let me just go back before I run this. Okay. Fat grams is private. So how do we indirectly access a private variable in a child class? Well, here's how. So when we create a pizza object, it asks for a parameter that's for a local variable called fat grams. Okay. Then we call super to access the parent, fat grams, comma 8. Okay. Go back here. Fat grams 8. Now, in order for you to see this, I have a Java application that creates a new pizza object and passes 275 as, what was that again? Fat grams. And I'm going to put a breakpoint here before we print out calories per serving plus special the object dot calories per serving. Now, in order for us to get calories per serving, which is a public method of the parent class, we're going to need to get a value for fat grams. Watch what happens. Food analyzer. I'm going to run this. Oops. Oh, I'm sorry. I need to debug it. Sorry. Hit that breakpoint. So here we are in the debugger. We're at this breakpoint, and let's take a look at the value in our variables. We've already created the new pizza object, right? 275, which took us into so 275 fat grams, right? And we called super fat grams comma 8. Let's take a look at our variables. Oops. Here we go. Oh, you can't see this. It's off the screen. Hold on. Here it is. Sorry. So, fat grams, 275, servings 8. And we go back to food item, fat grams, servings. There it is. So we accessed that private variable, fat grams, from the pizza object using the super reference. As always, I'm going to put these files in the timeline in Canvas, and I encourage you to download them and run them on your own machine. You must take your time and be very deliberate when you're designing the inheritance relationships between classes. This will reap long-term benefits for the design of your software, because inheritance issues are a critical component of object-oriented design. And if you have properly designed inheritance relationships, your program will be very elegant, maintainable, and you'll be able to reuse the software over and over again. So let's talk about some of the issues regarding inheritance that relate to good software design. Every derived class should be and is a relationship to the parent class. Pizza is a food item, etc. Car is a vehicle. Design classes to be reusable and flexible. And you must find the common characteristics of classes and push them as high in the class hierarchy as you can. Override methods as appropriate to tailor or change the functionality of a child class. You can add new variables to children, but don't redefine inherited variables, shadow variables. You have the ability to do this in Java, but it is a poor practice that often leads to confusing code and problems. Allow each class to manage its own data. Use the super reference when you want to invoke the parent's constructor to set up its data. Even if there are no current uses for them, override general methods such as toString and equals with appropriate definitions that may wind up being used down the line. Oftentimes, you're designing a class for a specific application, but you want it to be reusable, so you have to think beyond the current context or current application. And use abstract classes to represent general concepts that lower classes have in common. Use visibility modifiers carefully to provide needed access without violating encapsulation. Here we're going to discuss some tools to restrict inheritance. So the final modifier can be used to curtail inheritance. If the final modifier is applied to a method, then that method cannot be overridden in any descendant classes. If the final modifier is applied to an entire class, then that class cannot be used to derive any children at all. Thus, an abstract class cannot be declared as final. A final method or class establishes that it should be used as is. This diagram outlines the inheritance hierarchy in JavaFX. Everything is a node, and children of the node are shape, image view, and parent. Let's go into the shapes. So children of the shape class are text, line, rectangle, circle, ellipse, arc, polygon, polyline, and path. We use text, we use line, we use rectangle, we use circle, we use ellipse. I don't believe we used arc, polygon, and polyline or path in the examples in chapter 6 for the GUI, but it's pretty much the same. So, and then image view is a unique class used for displaying images, and we did use that. I'm trying to remember the example we used that for. Oh, the light bulb example, which is one of the last demos I did for chapter 6. And then we have all the other controls. And you have the parent class, region, and group. And from region, we separate, we have subclasses or child classes that are control and pain. And we used every single one of the child classes of pain. We used HBox, we used VBox, flow pane, grid pane, border. Yeah, we used border plane and stack pane. We also have children of control, choice box, text input control, which is a text field or a text area. And then we've got combo box, color picker, date picker, etc. And on labels, we have label, button base. And the base button class has button, checkbox, toggle button, and radio button as children of that class. So we covered almost every single one of these JavaFX classes in chapter 6. So this should not be foreign to you. We have a fairly complicated inheritance scheme in JavaFX. All the shape classes are derived from shape, which manages stroke and fill. Nodes derived from parent can hold other nodes. However, shapes cannot hold other nodes because they're not derived from parent. Any region can be styled with CSS. All layout panes are derived from pane. Controls have various intermediate classes to organize the common characteristics. Remember, you want to push the common characteristics upward as high as you can in the class parent-child hierarchy. So note the difference between the scene graph, i.e. containment, and the inheritance hierarchy. Only a parent can serve as the root node of a scene. So a pane derived from parent can be the root node of a scene and could contain a circle and a button. A choice box could also be the root node of a scene, but a rectangle could not because it's not derived from parent. That's the end of the lecture on inheritance. We've covered all the content in chapter 8 from our textbook. Thanks for watching. This is a very important concept moving forward. Please don't take this lightly. If there's any questions, you know how to get a hold of me, but please don't leave any stone unturned. If there's any of the concepts we've covered in this class that you don't understand, you must let me know and I'll help you either together, either solo or as a group. Get a couple of us together and talk about things that everybody's having a problem with. I have the time. So anyway, thanks for watching. Have a great day.